right, I received an email question about this 9.6 part 2, question 13, so I wanted to create a quick video to go over it. I am writing with my mouse right now, so just fair warning on that. Okay, and this is actually like my third try to get this recording software to work, so hopefully this is working. Let's see, so the problem says cosecant of theta is equal to square root of 2. We want to find all angles theta in the interval from 0 degrees to 360 degrees. So we know we want to answer in degrees. You also see this little degree symbol here, type your answer in degrees. Okay, so we're sure we want to answer in degrees. Cosecant though, so it would be nice to translate that into a more familiar function. It's hard to think in terms of cosecant, I feel like. So what we can do is use a reciprocal identity. So the fact that cosecant theta, here I go drawing with the mouse, doing the best I can here, forgive the messy writing, please. Cosecant theta is equal to 1 over sine of theta. So if we're looking for values of theta for which cosecant of theta is equal to the square root of 2, then that's equivalent to looking for values of theta where sine of theta is equal to the reciprocal, which is 1 over the square root of 2. Okay, great. So now, if we're using a unit circle, you might recall that sine of theta is given by the y-coordinate for each point on the unit circle. But here's another issue. I don't see 1 over the square root of 2. In any of the unit circles that I've been distributing to you guys, you don't see that value, or not expressed in that way, anyways. However, if you rationalize the denominator on this thing, so if you multiply the top and bottom by the square root of 2, then you will have 1 times the square root of 2 on top, so square root of 2, and then square root of 2 times itself on the bottom, so that'd be 2. So 1 over the square root of 2, this form right here, is equivalent to, when you rationalize the denominator, square root of 2 over 2. And so now we can think of this problem as we're looking for values of theta for which sine of theta is equal to the square root of 2 over 2. So now we can go over and use the unit circle to try to identify solutions. Remember that the value of sine of theta is given by the y-coordinate on the unit circle. So we'd be looking for when is the y-coordinate equal to the square root of 2 over 2. So if we're focused on the y, let's see, it's 0, 1/2, here we go, square root of 2 over 2 right here. And then if we keep going around, there's another solution here in quadrant 2. So sine of theta is equal to the square root of 2 over 2 at 135 degrees and at 45 degrees. And those are our two solutions here between 0 and 360. It's going to be 45 degrees and 135 degrees. So just to recap, a couple of stages to this problem. If you're given secant or cosecant, I would encourage you to change to the reciprocal function and just take the reciprocal of whatever value you have here. If you then have either sine or cosine, and if it happens to be one of the values that you see generated on the unit circle, like 1/2 or square root of 3 over 2, then you can just identify the angles that correspond to that value using the unit circle. If, by the way, you had something like, okay, well, I want to find where sine of theta is equal to, just theta, say 0.71, so that's not something we see on the unit circle, that's when you would use the inverse sine function on a calculator to start to work on a solution to that problem. But that's kind of a whole other problem, so I'm going to leave this video with just this.